Hello learners and coders, my name is Shawn and welcome to the Coding with Shawn channel. In this lesson, we will have an introduction to operating systems. Before we do get started, let me tell you how we're going to work this lesson. First of all, we're going to go into each major operating system that is used very widely in today's world, and after that, we're going to cover operating systems as a whole. And by the end of this lesson, you'll have a good idea of what operating systems are. And if you are one of the people who want to program using my channel, you will hopefully have an idea of what operating system you want to use while coding. So I hope you enjoy the video, and let's hop into it. Okay guys, so before we actually do get into it, I do want to say that of course I did not do this alone. I did research a lot before actually doing this, and so the sources that I did use are all in the description box below, and at the end of this video I will show them on the screen. So if you are one of the curious people who do want to see the sources, then yeah, those are there. So yeah, let's go ahead and get started. So there are 5 major operating systems that are used today in smartphones and computers. The ones that are most commonly used in computers are Windows, macOS, and Linux. I said those in the order that they are most commonly used. Windows is the most common, macOS following close behind, and Linux being in third. So for smartphones, the 2 major operating systems, which you've probably already heard of, are iOS and Android. You've almost certainly heard of them, and you probably use them too. So there is a 5th operating system on the screen, or excuse me, there is a 6th operating system on the screen that you can probably see, and that is Parrot Security OS. A lot of you guys are probably going to say, Parrot Security OS, what is that? Yeah, that is definitely one of the least common known operating systems that are on the screen right now, and the Parrot Security OS is definitely more secure than any of the operating systems that are on the left of it, but it is still very closed and not open source, and very few people actually want to use it because of how inefficient it truly is. But it is still a good operating system nonetheless if you are more concerned about security than actual performance and compatibility. So let's go ahead and get started on our major operating systems, in which the first is Linux. So Linux is a family of open source Unix-like operating systems that are based on the Linux kernel. I'm sure you guys have heard about the Linux kernel before. It's very famous, and a lot of people do actually use it when they program, but I wouldn't actually recommend it for beginners when they're coding because it is a little bit more complicated than the Windows or the macOS kernels. So the founder of Linux is Linus Torvalds. It was founded September 17th, 1991. The userland is GNU. It was written in the C programming language, which is one of the oldest widely used programming languages today. And as for the variety of Linux, there are many varieties. They are more or less pretty similar, and the kernel itself is the Unix shell and or GNU. Okay, so moving on, this one I think we've all heard of, and you're probably watching this on this operating system too. Windows, it is a group of several proprietary graphical operating system families, all of which are developed and marketed by Microsoft Corporation. So the founder was Microsoft Corporation, and we all know the founder of Microsoft Corporation, Bill Gates. And Microsoft Corporation was not actually alone in developing this. Some of its subsidiaries, like OneDrive, also did it. And in case you didn't know, subsidiaries of Microsoft generally have their own CEOs. So the CEO of Microsoft may still have a lot of control on a subsidiary like OneDrive, but he's not the actual CEO of OneDrive. So that may be a little complicated, and I probably will make a separate episode about that. But other than that, it is pretty similar, and Microsoft Corporation has full control over all Windows appliances. So this was founded in November 20th, 1985, making it one of the first operating systems to ever be made. And the userland is IA32, the x86-64, ARM, and ARM64. It was written in far more languages, including C++, C#, JavaScript, Visual Basic, and C. And as for the variety of Windows, there are many varieties. They are still very similar, and the kernel is Windows NT or Windows CE. If you do see the bottom of your screen, that little white thing, That is the monolithic kernel, which is MS-DOS for Windows 9X and earlier. But especially in these days, you will almost certainly never see a computer that is Windows 9X or earlier, and you'll certainly not work on those because those are very old and they are by no means compatible with today's softwares and today's speed. So next up is macOS, the second most popular operating system in the world, and it is a series of proprietary graphical operating systems developed and marketed by Apple Incorporated since 2001. So this is definitely one of the newer operating systems, and considering how popular it is, you do have to respect how fast Apple and macOS went into power. It is very incredible, and it is also a pretty good operating system. So the founder, of course, is Apple Incorporated. It was founded March 24th, 2001. The userland is NextStep, BSD, and Mach. It was written in C, C++, Objective-C, Swift, and the assembly language. And as for the variety of it, there are many varieties. They are very, very similar, and the kernel is hybrid or Z and XNU. So the next operating system is a smartphone operating system, iOS. You've certainly heard of this, and a lot of people have actually used it. It was definitely one of the most popular operating systems in the world. Android does have a higher market share than it, but again, this is way more popular in the United States of America. So iOS is a mobile operating system created and developed by Apple Incorporated exclusively for its hardware. These are the iPhones, the iPads, and some other things that are more minor. Of course, not Apple Watches, because those, I believe, are watchOS. And again, the founder is Apple Incorporated. It was founded June 29th, 2007, so this is an extremely new operating system for a smartphone. And considering how fast it has risen to power, you have to give Apple credit for making their operating systems grow so fast into power. It is truly incredible. So there are a lot of userlands. I don't want to read them out right now, so go ahead and take a moment to read those. Pause the video. Okay, so it was written in C, C++, Objective-C, Swift, and the assembly language, and so they're pretty much the same languages that macOS was written in. It's just a little different. And as for the variety, there are many varieties of it. They are also very, very similar, and the kernel is XNU. Okay, so next up we have Android. Before we actually do get into the specifics of Android, I do want to add that Android and iOS together make up over 98% of the mobile OS market share. So these are the true beasts of the market. Android itself makes 87% of the market, and iOS makes roughly 22%. So yeah, these are the true beasts, especially Android. So let's go ahead and get started with the specifics of Android. Android is a mobile operating system based on a modified version of the Linux kernel and other open source software designed primarily for touchscreen mobile devices such as smartphones and tablets. So the founders are various, but they are mostly Google and the OpenSet Alliance. So all you really need to know is that Android was formed by Google because almost all of Android is owned by Google and was created by Google. Open Handset Alliance really doesn't have much more than financial contributions. So it was founded on September 23rd, 2008, which is interesting because that is actually after iOS was formed, which is very, very special because Google has a knack for forming things before other people do. But in this case, they were behind, and the userland is 32 and 64-bit ARM, x86, and x86-64. It was written in a lot of programming languages, including Java, C, C++, XML, the assembly language, Python, Shell script, Go, Mach, and D. The variety, there are many. They are definitely not similar. If you have ever compared two Android phones, they are very, very not similar, other than the fact that they have basic Google apps, just YouTube, Google Play, Gmail, etc., etc. The kernel, of course, are modified Linux kernels, and again, this is where Linux kernel comes in. Linux kernel is incredibly useful, incredibly powerful, but it is not good for beginners. For beginners, I would probably recommend the Windows or macOS kernels because those are a lot easier to operate. Okay, so let's go ahead and get into operating systems as a whole. So what are operating systems? So an operating system acts as an or the intermediary between the utilizer of a computer and the actual computer hardware. The use of an operating system is to provide a way for users to use the computer hardware in an efficient manner. So think of this as a let's think of this in a metaphorical way. So think of the actual operating system as a translator. So you're talking to someone in a country where they don't speak the same language as you. Like say they are in China and they are speaking Chinese, and you're in the United States and you're speaking English. Well, the operating system would be the translator that knows both Chinese and English and is really helping you guys talk. And that's basically what's happening with the operating system. The operating system is translating your language as typing or moving the mouse or whatever into the actual computer's language. So an operating system is a software that manages the computer's hardware, of course. The hardware must provide felicitous mechanisms to ascertain the correct operation of the computer system and to obviate user programs for interfering with the felicitous operation of the system. So what this basically means is that the operating system is basically in complete control of the computer hardware, and it really takes the user's commands and makes the computer do that, and also make sure that the computer does not stray off and do something that it's not supposed to do. So these are the functions of the operating system, and operating systems must perform three main functions for them to be qualified as good operating systems and operating systems itself. So the first is convenience. An operating system should make the user hardware interface easier. It should not be so difficult to the point where it's easier to just code and tell the computer what to do than to move the mouse. That is unacceptable, and then it does not qualify as an operating system if that is necessary. Number 2 is efficiency. An OS allows the very, very efficient distribution of computer resources. This should mean that the computer is not wasting any energy where it does not need to be wasted. And this is very, very critical in operating system actual software, because obviously it's not good if your computer dies after 2 minutes because it is not distributing its resources properly. And the third is the ability to improve and be modified. This is really computer updates. An operating system should be made so that it can be updated and modified without interfering the main service to customers. So think about macOS or Windows. It really, like a new thing comes out, particularly in macOS. macOS is probably one of the easiest operating systems to update. Think about it. It just tells you that, let's just say macOS Catalina for macOS Mojave. It says macOS Catalina is available. It takes you about, maybe 10-20 minutes to update, and then voila. You can use your programs as usual, and it should not have deleted anything either. That is incredibly important and incredibly critical for an operating system to function. Okay, so moving on, there is I/O system management, that is input-output system management. So the module that keeps track of the status of contrivances is called the input-output traffic controller. Each input-output contrivance has a contrivance handler that resides in a separate process associated with that contrivance. So basically what this is saying is that, of course, a computer reads things as binary, input-output, 1, 0, off, on, and for this, there has to be a system manager that really controls the traffic, makes sure the computer does not overheat, or perform more processes than it really needs to, as the actual person does their thing and types or moves the mouse or whatever that really needs to do. So the input-output subsystem consists of a recollection management component that includes buffering, caching, and spooling, a general device driver interface, drivers for concrete hardware contrivances. And then there's an assembler. The input to an assembler is an assembly language program. The output is an object program plus information that enables the loader to prepare the object program for execution. At one time, the computer programmer had at his disposal a rudimental machine that interpreted through hardware certain fundamental ordinate dictations. He would program this computer by inditing a series of ones and zeros, which is machine language, and place them into the recollection of the machine. So what this really means is that the user interface has gotten a lot better over time. At one point, the computer program pretty much literally had to type ones and zeros to tell a computer what to do. But as these operating systems rolled around, they made the interface so much easier, so much faster, and so much overall more convenient. And that is the major, major benefit of operating systems, and this is why they are so critical in today's life. So the main types of operating systems are batch operating systems, which is a operating system runs a series of programs in a computer programs, such as when you open a web browser such as Google Chrome, your operating system opens a series of DLL files, which are basically the individual pieces of Chrome without your manual approval, as long as you just approve Google Chrome to open by clicking it. So if you do not know what DLL files are, they are really just the critical pieces of any exe file, any DMG file, any file that you download on your computer. Those are the individual components. So like one DLL file might be the search bar, one might be the logo, one might be your history, etc., etc., etc. The other operating system is a time-sharing operating system. This really allows many users to use a computer on seemingly separate accounts but are actually the same. This has the max utilization of the resources. So think about this as a school computer. If you have ever been to a school or even a university and just seen one of those computers, you know that they are all on one major hard drive, but they are separate accounts for each university or each school student. And this is incredibly useful for the computer so that it does not have to open a separate hard drive or separate software each time a student or a faculty member opens a different account. So the other kind is a distributed operating system. This makes the groups of computers the same for a user. So think about this as one person using one computer, but he has a lot more of PCs and monitors and all of that. It really makes all of these computers into one main operating system. The other kind is a network operating system. A group of computers run as one via a network. It is generally utilized for security, and this is often used in Parrot Security OS, but it can also just be for businesses or enterprises or educational facilities to promote easier and more convenient usage. This is the other operating system that can also very commonly be used in those universities and schools on their computers so that they do not waste any resources on their computers that they do not have to waste. So examples of operating systems and their usage are Windows, which is a GUI-based PC, GNU or Linux, which is personal workstations, ISP. There's a file and print server, and a 3-tier client or server. And there's macOS, which is Macintosh, and it is used for Apple's personal computers and workstations, which is, of course, the MacBook Pro, the MacBook Air, all MacBooks, the iMac, and Mac drives, which are just portable Macs that you can really put in any monitor to get your Mac computer to start working without actually buying a complete MacBook or a complete iMac or something like that. And then there's Android, which is of course the Google-owned OS used on smartwatches, smartphones, and tablets, and much more actually if you do ever search the Google catalog. And then last but certainly not least, iOS, which is Apple's OS for iPhone, iPad, and iPod Touch. So every computer must have an operating system to run other programs. The operating system coordinates the utilization of the hardware among the sundry system programs and application programs for sundry users. It simply provides an environment within which other programs can do subsidiary work. The operating system is a set of special programs that run on a computer system that sanctions it to work felicitously. It performs rudimental tasks such as apperceiving input from the keyboard, keeping track of files and directories on the disk, sending output to the exhibit screen, and controlling peripheral contrivances. So if you do not get this, then in a gist, what it means is that an operating system takes the input from a user, does some translating, like that person would do in that example where you are talking to someone who doesn't know your language, and it gives it to the keyboard in its binary language. All computers, to this day, still run on zeros and ones, which are binary, but there have been more complex systems in which finally users can actually type something, and a translator, which is the operating system, will tell the computer what to do. An OS is designed to accommodate two fundamental purposes. It controls the allocation and utilization of the computing system's resources among the sundry utilizer and tasks. And two, it provides an interface between the computer hardware and the programmer that simplifies and makes feasible for coding and engenderment and debugging of application programs, which is very, very important. Operating systems can fix problems without you even knowing. You'd be surprised how many times an operating system actually clears a problem without your approval or even you noticing, and that is incredibly important. Back in the day, where a computer programmer had to tell a computer programmer had to tell a computer what to do using zeros and ones, not only could it take hours, not only could it take days, not only could it take weeks, but it could take months, years, and in rare cases, even years to just solve a simple bug. And this is why operating systems are so useful and so efficient. And it really controls the computer and makes it so much better than it could be without operating systems. Okay, So that is where we're going to end in the introduction to operating systems. So please do check out my other videos on programming languages and more stuff. And of course, please do subscribe and like the video to keep us going. And if you do have any questions, I'm always open for questions in both the comment section and the discussion tab on my channel page. Thank you guys, all my viewers, all the guys who like my videos, and especially all the people who are subscribed. Thank you so much, and I hope you keep staying with me and keep watching my videos. Thank you so much. See you in the next lesson.